Hi, I'm Steve from Dulux Protective Coatings, and welcome to the introduction to protective coatings and corrosion basics. The main function of protective coatings is to protect the substrate from abrasion, chemicals, moisture, and other contaminants within the environment. Their high performance characteristics provide long-term durability and protection of a substrate such as mild steel, galvanized surfaces, and concrete surfaces. The main differences between protective coatings and decorative coatings is that protective coatings are mostly two-pack products applied at higher film builds in multiple coats to protect the substrate from corrosion. Decorative coatings, on the other hand, are mostly used for decorative purposes at a lower film build over plasterboard, timber, and masonry type substrates. A typical protective coating system comprises of a primer, an intermediate, and finish coat. The main function of the primer is to seal the substrate from corrosion and to provide good adhesion for the subsequent coats. The intermediate coat provides a barrier to moisture, ions and oxygen. Usually this coating is epoxy based due to the exceptional cohesive strength and impermeability of epoxies. Epoxies, however, tend to surface chalk when exposed to UV light, sunlight, and therefore require UV resistant top coats where aesthetics are important. The finish coat has a number of functions including UV resistance, colour and chemical resistance. Top coats can also provide other properties such as graffiti resistance. All of these coatings have an important part to play in the overall protective coating system. The cost of managing corrosion can be massive, and it's important to preserve and maximise the initial investment. Corrosion of steel is an electrochemical reaction that requires the presence of water, oxygen, and ions such as chloride ions, all of which exist in the atmosphere. Let's discuss the different types of environments and atmospheric categories. Each corrosivity category has a code and a description. The categories range from C1, very low, C2, low, C3, medium, C4, high, C5I, very high industrial, C5M, very high marine, and lastly T, inland tropical. All of these environments and their categories identify what type of corrosivity the environment has and what types of coatings are most suitable for protection of a substrate such as mild steel within that environment. How do we stop steel from corroding? There are three methods that may be used to protect steel. 1. Passive barrier protection. Passive barrier protection works by coating the steel with a protective coating that forms a tight barrier to oxygen, water, and ions. The lower the permeability of the coating system to water, the better the protection. Two-pack epoxy coatings and chlorinated rubbers applied at sufficiently high film builds offer the most successful passive barrier protection. 2. Active protection. Active corrosion protection occurs when a primer containing a reactive chemical compound is applied directly to the steel. The reactive compound disrupts the normal formation of anodes on the surface of the steel in some way. For example, inorganic zinc inhibitive pigments such as zinc phosphate offer active anti-corrosive protection to the steel substrate. And 3. Sacrificial protection. If any two dissimilar metals are in contact with each other, the more reactive metal will corrode in preference to the less reactive metal. This is the basis of galvanic sacrificial protection. The most widely used metal for the protection of steel is zinc. Zinc metal in direct contact with the steel substrate offers protection through the preferential oxidization of the zinc metal. Zinc is a great choice in protecting steel, as not only does it corrode in preference to the steel, the rate of corrosion is generally lower. Examples of coatings using this principle of sacrificial protection include organic zinc-rich primers, hot-tip galvanizing, and electroplating.